Hello everyone, I am Sunandini Sanyal from the Department of Computational and Data Sciences, IISc Bangalore. It is a pleasure to present our work, Domain Specificity Inducing Transformers for Source-Free Domain Adaptation. Before we delve deeper into our approach, I would like to give a brief introduction about the source-free setting in domain adaptation, where a vendor trains a model on a large-scale proprietary labeled dataset and shares it with a client. The client then uses its own unlabeled target domain dataset, which is usually small scale, to perform target adaptation of the source model. For domain adaptation, a model requires learning of task-specific factors that represent the goal task-related features and domain-specific factors that represent the domain-related features. Conventional DA algorithms only focus on learning the task-specific factors that are domain invariant. However, domain invariance does not always guarantee the best performance since domain-specific models preserve the crucial in-domain characteristics that help the adaptation process. Hence, in our work, we address the key question: how do we develop a framework that enables us to leverage domain specificity for SFDA? In our approach, we focus on equally learning both domain-specific and task-specific factors. This not only yields better performance, but also ensures that different domains are well clustered in the feature space. Now, we first formulate our core insights. Insight 1 states that domain specificity leads to improved DA. This is because an in-domain trained model better captures the crucial domain-specific factors. As shown in the figure, the optimal task-specific factors of a domain-specific model might be far away from the task-specific factors of a domain-invariant model, especially in scenarios of large domain gap. Hence, we note that it is important to inculcate and learn domain-specific factors for improving target adaptation. Insight 2 states that disentanglement and learning of task-specific and domain-specific factors provides a better way to learn the two factors. Conventional approaches update all the model parameters, which leads to loss of the source domain goal task knowledge. Conversely, our approach disentangles the feature space into domain-specific and task-specific factors and simultaneously learns the two factors. This enables better control over them, leading to improved DA. Here are some of the major contributions of our work. We develop a novel domain specificity inducing transformer for disentangling and learning both domain specific and task specific factors. We construct a novel DRI to train the domain classifier. We are the first to utilize vision transformers for SFDA and achieve state-of-the-art performance on various benchmarks of single source, multi-source and multi-target DA. We develop a domain specificity inducing transformer framework that comprises of 3 steps. Let's understand each step in more detail. The first step is the domain representative input DRI creation. For this, we take the dataset and create augmentations to simulate virtual domains. To preserve only the domain-specific information, we apply task-labeled destructive transform of patch shuffling. Hence, DRIs are not a generic augmentation, but are mainly used to train the domain classifier to disentangle the domain-specific factors. Once the DRIs are created, we train the domain classifier with them using the domain classification laws as shown in the equation. We propose to utilize only query weights in each transformer layer to learn the domain-specific factors. This helps to better control the task-specific factors, while the query weights learn to extract the domain-specific information. After one round of domain classifier training, the remaining weights except the query weights are trained with the goal task classification laws. This ensures that the task-specific factors are disentangled and learned along with the domain-specific factors. Our approach well fits in the SFDA paradigm, where the vendor first performs the disentanglement and training of DSET using all the 3 steps and shares the prepared DSET model with the client. The client also follows the same process of DRI creation, domain specificity training, and goal task training. We demonstrate state-of-the-art results in single-source DA benchmarks of Office Home. Similar improvements are observed for Office 31 and Vista dataset. Our method shows significant improvements over prior multi-source and multi-target benchmarks. In short, we propose a novel transformer-based framework to learn domain-specific and task-specific factors, and our approach achieves state-of-the-art results over multiple SFDA benchmarks. Thank you. Do visit our poster session for more details.